Here the computer starts and at Preboot detects the user's phone using Bluetooth. Once the phone is detected, the user will be prompted to authorize the device login and re-authenticate using the phone biometrics. Only a phone containing the correct key can access this device. This login can occur while the device is online and offline. Using single sign-on, the device will now boot directly into the desktop, ready for the user to start accessing online applications. To demonstrate how the device trust signals work, we have created a policy requiring devices to be fully encrypted. If a device is not fully encrypted, the user will not be able to log into online applications on this device. To test, we can see that the user is able to log into Microsoft 365 automatically using the MagicEndpoint IDP with no user action. And now we will log out of Microsoft 365. To test the device trust signal policy, we will log into the console using Bluetooth to start the decryption process. Of course, the user would require elevated permissions to perform this action. And because the endpoint has a persistent connection with the MagicEndpoint Center, this event-driven action is detected. Because the endpoint is being decrypted, the policy takes effect immediately. When the user tries to log into Microsoft 365 again, they will be denied access. By looking at the logs, we can clearly see that the device check policy indicates the reason for the access denied failure was due to the endpoint not being fully encrypted. Here, the device waits for the user to authenticate using their PIV card. However, because the smart card was not inserted, the login process fails. When the user inserts the correct smart card, the login is successfully completed and the device logs into the desktop using single sign-on, ready for the user to start using their online applications. In this case, the user will log into Microsoft 365. The endpoint informs the MagicEndpoint IDP of this action, and since MagicEndpoint knows the validity of the user and device through continuous verification, it can simply approve the user access to the service provider. This is considered no user action. Now, let's see what goes on under the covers when the user gets no user action access to an online service. It is actually quite a lot. Many systems allow the user to connect from any endpoint by, for example, just accepting a push prompt on their phone. The problem here is twofold. A, the endpoint device could be any device, not just the one used by the legitimate user. Or B, there is no association between the legitimate endpoint and the user's phone. Accepting the push request on the phone could actually be giving access to an attacker half a world away. We solve this problem by having a clear association between the legitimate user and device. With this association established, MagicEndpoint can actively verify the user's intention to access the specific service from the specific device. This is protected with FIDO public key cryptography. Together, this provides phishing resistance authentication with no user action. To demonstrate the support for multiple users using the same device, the next user will log into Windows using an incorrect smart card. An error appears. When using the right token, in this case the YubiKey, the user will be able to log into Windows and into the desktop. And now, since the user is logged into this device, a new user and device identity is created. This makes sure that only the authorized user logged into their device can access their online application, in this case, Microsoft 365. We just demonstrated that users only need to authenticate to their endpoint, and the endpoint with Magic Endpoint Center will authenticate to everything else for the user.